and share my screen. And yes, welcome everybody back to data structures. I apologize. Well, I guess it feels like it's been a while since I've seen you all. Apologize. I had to cancel the Wednesday class last week. Monday was my kid's birthday, turned 2, and I think I was already starting to lose my voice a little bit by the end of the day, but in the middle of happy birthday, it just totally gave out. And then I basically couldn't talk until Thursday. And then hope you all enjoyed your Friday off with Cesar Chavez Day. I'm hoping that we will actually have a lab sort of related to Cesar Chavez, and I normally try to time it so that it coincides with the actual holiday. But because I'm trying to make sure that we get everything that we have to cover covered before our again, April 18th, 2 weeks from now, is when my child is due. And so that'll be like our last set of lectures then. I want to make sure that we cover all the things that we really need to cover before then. So it actually turns out that in California, we're one of the few states in the country that's this way. In the name Cesar Chavez, in Spanish, you add the accent mark over it, but in California, you cannot have accent marks in names for historic computer technical reasons. And I hope we'll get to talk about the details of that, but we will see. Other things more pressing for us at this point. So 2 announcements that I have just posted at the beginning of the class. The first one is just so that we're all on board with our upcoming quiz schedule. Again, last week, because Wednesday's class was canceled the quiz. It will happen this week instead. And the way that we're going to do this is that we will have 2 quizzes on the same day this week. And you'll have 16 minutes instead of 8 minutes to work on them. Again, I will be here early. I'll try to be here even a little bit extra early so that you can have plenty of time to work on these. I don't want them to be time limited, but I do want to make sure that we are able to have cover all the material that we need to. So we'll have the 2 quizzes in 1 week on Wednesday. And then today in class, we're going to cover some follow-on material, this Posix 3 quiz material. I've posted, there's printouts of the practice problems over there, and the electronic version is in our topic 9 folder, this quiz practice.pdf right here. And then, the last due date-ish thing for us to highlight is, again, your heap assignment due this Thursday. Question?
Can I ask a question? Generally,
yeah, go ahead, ask.
You told us to ramp off from branch that there are APL test cases and BST test cases on where we're pulling from. What do we do about those?
So the only test cases that matter for the purpose of grading the heap assignment are the test cases for the heap class itself. So if some of your other previously green badges turn red, that's acceptable. Did that answer the question? Cool. Yes, question. Question is, will there be points deducted if you modify the BST or AVL branch? And the answer is that you shouldn't do that. I probably won't go in and check all the different branches in super detail for things, but if you're finding yourself modifying those other branches, then you're probably doing something wrong. Yeah, so I'll talk a little bit more here about the motivation for the heap assignment and having us Well, yes. Yes, pause the heap assignment. I just want to mention this other issue here, and this will tie in a little bit to the heap assignment here. So I'm making an extra credit option available. I've just posted this 8 minutes ago. There's a lot of explanation here, so I'll go highlight what it is. And the overall idea of like my grading philosophy, or really the philosophy of what gets included in this class, is twofold. That one is I want you to be exposed to like real world computer programming things that you're going to actually use in practice after graduating. And the second one is that I want all the things that we're doing in class here to actually get you jobs in the future. And so all of these assignments that we're working on are somehow related to that. And if you can demonstrate that you've mastered all that material, I want you to be able to get a good grade in this class. There's this website called LeetCode, which is very popular in the interview situation, especially for new graduates right now. And the idea of LeetCode is that you're given some sort of problem. Go away, Zoom. Let's see, like this one, some sort of problem description on the left-hand side, and there are some test cases for this problem, and you have to write code that satisfies those test cases. And I've put a couple links in here about how these LeetCode problems are used in the interview environment these days. But the particular of the extra credit is that these problems are divided into easy, medium, and hard problems. If you complete a medium problem, you'll get 1 point of extra credit. And if you complete a hard problem, you'll get 4 points of extra credit. You can get at most 2 points of extra credit for medium problems, but there's no upper bound on the amount of extra credit you can get from hard problems. So no matter what your current grade is in the class, you could get above 100% by completing these hard problems. After taking this class, at this point in this class, maybe about 20% of these LeetCode problems are things that you have been exposed to for how to solve them. So there are a lot that you just haven't seen the material how to solve. The class that covers that is CS148, graph algorithms, normally taught by Professor Sarah Cannon. But I've selected a couple of sample problems here. You can see they're basically all related to binary trees. Things that you can take a look at about, you should know how to solve these problems, or it's not maybe immediately obvious how to solve them, but you've seen all the basic material for solving them. And so, yeah, I'm offering this as extra credit again, so that you can demonstrate the knowledge for this class, but also preparing yourself for the future interview situation. And I brought this up at this point, talking about the heap assignment, because one of the things that I want the heap assignment to do for you all is prepare you for these future interview situations. That on these previous assignments, I've been very much encouraging you all to work together on the assignments, so that both you can actually learn the material better, get exposed to how other people are doing programming, and just develop good practices about collaboration. But one of the purposes of this heap assignment, for having this more like cloistered, work on your own sort of attitude, is because if you're going off to an interview at Google or Facebook or a random startup that nobody's ever heard of yet, but will in the future be worth billions of dollars, they will sit you down and say, you can't talk to anybody for an hour, solve as many LeetCode problems as you can. And those LeetCode problems have this same format of our heap assignment, where there's some test cases that you have to program. And so I want you to have some experience of working in this environment as well. All that said, if you do have questions about things, I'm still happy to answer those questions in office hours or over email. I think I have a handful of emails from the weekend from you all that I haven't had a chance to go through yet. I'll try to get through all those today. But definitely feel free to come to office hours and ask questions about things if you have questions. Any questions about anything that we've talked about administrative-wise? Okay. So today in class, we're going to be talking about this Posix Shell 3 material. And this will all be related to this thing called the glob operator, which we'll be talking about in detail today. Again, all of these things that we're talking about with the Posix shell, these are things that I have never heard of ever coming up inside of an interview situation, but they always come up or very frequently come up in practice. And actually, when I say they don't come up in interview situations, I mean that nobody specifically asks questions about them. But it's very common when doing interviews that people will just be looking over your shoulder. And I know that as people are looking over your shoulder and seeing the sort of techniques that you're using, if you're using these shell techniques correctly, that's a huge thumbs up in people's sort of mental scoring of you, because they're just very, very efficient ways of solving things. So we're going to talk about this today, about why it's efficient, why it's good, how it will be useful for you in practice. Before we get to this, I'm going to do some quick demo here in the terminal that will help illustrate the glob, but it'll also help illustrate some of the things that we've been talking about in the previous quizzes. So let me real quick remove that. So I'm in this quiz folder right now on the top, and there's nothing in this folder. And I'm going to create a file example.py. And I just want to do, this is going to be a very short Python file, and I want to see how Python can interact with the terminal down here, and how Python relates to some of these terminal things that we've been talking about. And in particular, there's this module called sys. It's short for system, that anytime we're interacting with the operating system or the terminal, all of these things are contained inside the sys module. It's built into Python, not something that you have to pip install. And I want us to look at the sys.exit command right here. Sys.exit. So there's a very short Python program right here, import sys, and then sys.exit right here. We'll add one more line actually, like this. What sys.exit does is it exits our program immediately and does not run any more code in our program. So line 3 down here will never get ran. Type Python 3 example.py like this, you can see that that code down here was never run. The question is, what is this number inside the parentheses? What is this number doing? Well, this is the number that determines whether the program is evaluated as true or as false. So here, again, I have my terminal command. It's to the left of an and. So I'm only going to do this command on the right. I'm only going to do this command on the right if this thing over here evaluates to true somehow, because of that short circuiting procedure in the and operation, that if this thing is false, we never even consider this thing over here. We never run it. So I'll hit enter, and you can see that we never actually run this echo hello world over here. The reason is because this, we call this a status code here, the number that you put in the exit, the number in the sys.exit is called the status code of the program. And it turns out that in the shell, everything is sort of backwards from Python, that 0 is like true, and anything else is like false. So because I have a non-zero number right here, this is treated as false by the terminal down here, and we do not run this code over here. If I change that 1 value to a 0 value, so now that will be what the shell interprets as true, even though in Python that's more of a falsy value, and run this, then you can see that I run hello world, because this thing over here has the exit code of 0. And so we, by the short circuiting, we will run both of these commands instead of just one of them. This is not on your quiz for this Wednesday, but there's a little bit of review from your quiz that you'll be having this Wednesday. Any questions about what this exit function is doing, or the status code? Okay, in the terminal, let's see, if I do Python 3 example.py, in the terminal, there's a special variable built in called $ question mark right here. And this gives you the status code, of previous command. So here, Python 3 example.py, we had a status code of 0 right here. And so this echo command right here gives me 0, gives me that status code of the previous command. If I change this, say, to a 10 like that, come down here, rerun that, rerun my echo command, we get 10 down here. So this could be a potentially very useful thing for you while you're working through the Posix 2 problems, understanding why did something short circuit or not short circuit? Why did something get evaluated to true or false? Here you can actually look at the status code of the previous commands. And so if I do something like true, we can see that the status code of the true program is 0 because we get 0 out here. If we do false, the status code of false is 1. And that's why false is treated by false, like false, because it has a non-zero status code right here. Similarly, with this square bracket command, I can do something like hello equals world, like that. And we'll see that that evaluates to false because these two strings are not equal to each other. But if I change that to hello equals hello, then it's 0 because those two things are equal to each other. Okay, one more thing about about Python interacting with the terminal and this sys module, and that's that the sys module has an attribute called argv. I'll do @p here to print that out, and we're going to see how this looks right here, and we'll see how that relates both to the Posix 1 quiz and the stuff that we're going to talk about today. So down here, let's reset this terminal and let's do Python 3 example.py and hit enter. argv, what it is it's a list of all the arguments. argv is a list of all arguments passed into the command line. The very first argument is always just the name of the file here. So example.py. And if I add more arguments like A, B, C, like this, you can see that this list has more arguments added into it, like the A and the B and the C. If I add some quotation marks around A and B like this, what we'll see, so I'll hit enter here, what we'll see is that actually the terminal, the shell, is interpreting these quotation marks here before passing them to Python. So here, A and B right here, these two letters here are inside of the same argument right here because in the terminal, we put quotation marks around them. So that forces them to be the same argument, not at the Python level. Python doesn't interpret these quotation marks at all. It's inside the terminal before we even get to Python. This is the what the terminal literally passes over to our Python program. So these quotation marks are happening inside of the terminal, and so it's something that's available to all programs everywhere. You don't have to do anything special for it. We're about to see something, this glob operator, which is very special and very cool, and it'll be extra cool that this is happening inside of the terminal and not something that you have to program manually inside of your programs. So here inside of my quiz folder right now, I only have a single file here, this example.py. Let's add a couple of other files. We've seen like .sh files like this, and let's just add an A and a B file like this. So we have 4 files in here now. And this glob, which looks like the star like this, the glob lets you expand, do pattern matching on files to get them to be passed into the arguments of a program. So up here, if I do Python3 example.py and then star, you can see that right here, it looks like I only have one parameter that's being passed into my example.py program. But if I hit enter, you can see that this star is getting what we call expanded. The shell is expanding this glob operator right here to be all of the files in my current folder. Here, when I did ls, we saw that there's these 4 files right here. And so now when I do Python3 example.py glob, this star gets expanded to be all 4 of these things right here. You can do complicated patterns with this glob operator. So for example, when it's the glob all by itself, this will get you all of the files. But if I wanted only the files that, for example, started with an E, so I would get these files right here, but not these files right here, then this pattern right here says it must start with an E, and then it can follow anything else. The star means it can be anything else at all. So I hit enter, and now this gets the example.py and example.sh, but not the A and the B files. So this glob, again, 2 important things that we've seen so far is that this is part of the terminal, not part of Python, not something that programs have to do anything special for, that all that it's affecting is what are the actual values that get passed into the Python program or whatever other programming language people were using. The glob operator, the star, only affects what gets passed into the program. But the program itself doesn't have to do anything special to implement this. The other thing is that you have these patterns where you can specify particular letters like this, saying E star, and then it must start with the letter E, and then it can have anything at all after that. It's common to do something like star.py, for example, to list all of the Python files in a folder. Do that, star.py. And this gives us all of the Python files. There happens to be only one in this case. Example.py is repeated twice down in sys.argv because the very first parameter is always the name of the file that you're running. And then the second parameter is what's actually getting passed in over here. Any questions so far? Yes. Question is, how does this relate to the grep command that they seem to be doing similar things? And so what's going on? With the grep command, grep, we are always having to have our input as standard in. So here, when I do ls pipe cat right here, this is the output that we're looking at of the cat program. And if I wanted to do some filtering on this to say only get the Python files, then I could pipe that to something that looked like grep py like this. And the grep command here, what it's going to do is from standard in, it will get whatever matches this regular expression over here. And this will be the only line right here that matches that regular expression. And so we print out example.py. It's very common to use the glob operator in a situation where you're not using things from standard in. One of the most common ways to do it is if I do, for example, so here, what I'll do, I have example.sh. I'm going to create one more sh file. We'll call it touch example2.sh, and we'll actually just create a couple of these. It's common to want to do a bunch of operations on the same files at once, something like removing those files, rm star.sh like this. And this right here will pattern match, expand to all of these shell files right here. And then we will delete them with this rm command right here. ls, and now there's no more shell files. So the glob here is happening at the parameter level, happening at the level of file names being passed into a program through the command line parameters, whereas grep is happening at the level of standard in over here, filtering what goes from the inputs to the outputs. That's one main difference between grep and the glob. Another difference, and this is a confusing one, is that grep uses regular expressions. If you've seen that before, if you haven't, that's okay. One of the commands in regular expression is that star is a regex command, but the glob operator star is different from the regex star, and there's actually no relation between these two things at all. So it's easy to get these two things confused if you're already familiar with regular expressions. If you're not already familiar with regular expressions, then you don't need to worry about that. Did that answer your question? Good question. Yes. So let's see. So let's rerun our example.py, and I think I know what your question is, but I'm not sure. What happens if, we'll start just by putting the glob right here, and here it's matching everything. It matches all three of these files. And we saw that there's special things that you can do, like, okay, if we put the example right here, it's going to match the example.py. If we just have the letter A right here, it'll match A. You don't have to have something for a star, but you are allowed to have something. But what would happen if we had, for example, like a C star? This is not going to match anything in the current folder. And one of the confusing things about the glob operator is that if it does not match something, then it gets passed literally as the contents to the program here. So here C star does not match anything because there is no file in here that starts with the letter C. So this glob operator does not match anything. So the terminal literally passes C star as the first parameter to the program up here. If I were to create a new file here called something like touch cat. So now we have a file that starts with C. I'll rerun this same command right here, and now the C star expands to cat. So if the glob operator does not match something, then you get literally the glob operator being passed in. If it does match something, then you get the files. Was that the question you were asking, or is that something different? Oh, the question is, why is this example.py right here? With this command right here, why is example.py right here? The answer is because I'm just running this Python program right here. If I just had Python 3, I'd be going into the interactive mode. So this example.py is just this short program up here, this 2-line thing that just outputs what the parameters are. Yeah. So if we do cat example.py, it's what I have currently open in Vim. All good questions so far. Any other questions at this point? Okay, then we're gonna start going through the quiz material here and see how, like, some practical-ish examples of this glob operator. Again, thinking about the quizzes, I think about them more as the how and the what of these operations, like just making sure that you understand the edge cases of all of these operations. When we get to our one of the assignments that we're building up to is analyzing this big data set of multiple terabytes of tweets, we'll see how to use the glob operator sort of in anger at that point in order to talk about the why of using the glob operator, and we'll use that to filter out our tweets in a nice way. For this particular quiz, I have these notes which have like a short explanation under each of these sections about the things that you need to know. So far, we've talked about this star operator, but we have not talked about this question mark operator. Both the star and the question mark are considered examples of glob operators. And what the question mark does is that, let's say we have cat right here, and let's also have bat like this. So cat and bat. If I type ls question mark at, the question mark means that it has to match exactly one character here. So question mark at will match bat and cat. In this case, star at also only matches bat and cat. But if I also have, say, drat, then ls star at will match the drat because the star matches any number of characters, 0 or more. Similarly, if I just have touch at, this will match the at by itself as well. But if I change that star to a question mark like this, the question mark means exactly one character. Doesn't matter what that character is, but exactly one character will be matched. So bat and cat get matched right here, but the star at matches all 4 of these things. Question, yes. Question is, okay, I mentioned this is different than the regular expression. How is it different than the regular expression? The answer is that in regular expressions, these operators, the question mark and the star, they require a parameter to the left-hand side. And so I'll do a 2-minute divergence into regular expressions here. If you haven't seen that before, then it's okay to just totally ignore this 2-minute chunk of what's going on. If you have seen regular expressions, this might elucidate what's going on here with these. So the grep command does regular expressions. If we do ls pipe cat pipe, so ls pipe cat again, we'll list all of our files right here. If we then pipe into grep and let's just do the star like this. You'll see that this does not match anything at all. But if I do ls star, this matches all of these things. The reason this does not match anything at all is because the star operator requires something to the left-hand side, something like a dot to the left-hand side. Dot in regular expressions means match any character at all, exactly one version of that character. And so this matches everything. But if I were to do ls dot star, you can see that this has very different behavior. Python 3 dot stars, example.py dot star, that's the better thing. Here's what gets matched by dot star. It matches the dot, and all of our hidden files over here, because the dot must be the very first character of our file, and then the star means match anything at all after that. Similarly, for the question mark in regular expressions requires there be something over to the left-hand side that gets matched, but in the glob, see this, so this here matches nothing. If I did that, that matches the dot right here. So there, maybe I was a little bit too strong when I said there was no relation between the question mark and the star operator in the glob versus regular expressions, but there's a very tenuous relationship. Technically, the glob operators came first. These were invented at a time when nobody knew like what regular expressions were, and then the syntax for regular expressions was adopted to be analogous with these glob operators here. Happy to talk more about the regular expression details if people have questions about that after class or in office hours, but that'll be the end of our regular expression digression here. It was a great question, though. Any other questions at this point? Okay. So I'm going to come back over here and we're going to actually walk through these quiz problems down here. But when I do this, when I run this first line up here, we'll recall that this line totally deletes all of the contents of our current folder. So that's going to delete this, this debugging file that I created up here, this example.py. The reason I created it is so that we could see exactly what gets passed in as parameters to a program. It lists out all those parameters right here. We have another tool for doing that, though. The echo command will also allow us to list out all of the parameters that get passed in. That's what echo does, is it just prints out the parameters over here. And so we can use echo combined with star to see this same information. And that's what I'll be using to debug through the quiz. So as you're preparing your or reviewing the quiz, studying the quiz, this will be a good command to use to debug what's going on, what gets pattern matched with the star over here. So again, if I do something like echo star py, this will only print out the example.py. Or if I do something like a star, then it will get a and at, or the question mark at like this will get me my bat and cat and nothing else. But again, I'm just emphasizing that we will not be able to use this example.py file anymore because we'll be deleting it here. And so we'll be using echo now to examine what the actual command line parameters are. So Control R, CD, if I have that, there we go. There's the command, run that. Now there is nothing in this folder anymore. And I will move that terminal up out of the way, reset this screen so it's totally empty, totally clear, fresh start. Now we can think about the quiz problems. Problem number 1 right here. So we just cleared off the screen. We have 3 of these touch commands right here. Hello world, hola mundo, salve mundi. Touch, hello world, touch, hola mundo, touch, salve mundi. And then on line 5 here, we have an rm command that contains these 2 glob characters right here. And so we have to figure out first of all, what are the files that currently exist inside of our folder? So we have these 6 files right here. In order to figure out that these are 6 files that are created, we have to understand that each one of these is 2 separate command line parameters being passed to this touch command. Hello and world are 2 separate parameters because there's no quotation marks here. And then when I do the rm star e star like this, I have to figure out which one of these lines here will match the star e star, and those will get deleted. Before I run this, a good way, again, to test what's going on is to use the echo command star e star and see what exactly gets matched here. So here we can see that hello and mundi and salve are the things that are getting matched. And so when I do rm star e star, those will be the files that have been deleted. And now these are the files that remain, hola, mundo, and world. Basically, this is going to delete anything that has the letter E anywhere inside of the file name. And then the very last line over here, listing all the files and then counting pipe WCL, how many of those files there are, WC-L, so 3 here. So it's testing a lot of things here in this one problem, both that you understand how these are creating 2 separate files, then also how the star e star matches certain files up here, and then also how the pipe connects the ls with the wc-l commands. Any questions about any of that? Okay. I'll just highlight that let's see. So a common thing to do is to do rm star to just delete the entire contents of a folder, rm star like that. Now the folder is empty. And I wanted to highlight that if we were to change how these touch commands up here worked by putting quotation marks around them, that will change the result down here. So hola mundo, salve mundi like this. And now if I do the ls pipe cat, we can see that there are 5 files created instead of 4 files because we have the quotation marks around this. So the space doesn't separate the parameters. And now if I do echo star star e star like this, We can see what things are going to match here. It's a little bit hard to tell with the echo command that hello world right here is all one file by itself, and then Moonday and Salve are separate files. We could use the ls command to list all the files individually, and here it'll put that in quotation marks so we know that it's a single file right here matching this file up here. And we could even pipe that to the cat command to get everything listed on its own line. And then these 3 lines here are the things that will get removed up here when I do the rm star e star. And then, so there's originally 5 lines. I've removed 3, so now there should be 2 left. So ls pipe wc-l, and we get 2 as the answer in this case. So it'll be important that you're combining your knowledge of quotation marks with all of these things. And it'll also be important that you're understanding the difference between the different types of quotation marks and when variables will be substituted and not substituted. All of those things will be coming together in this quiz. All of that takes us through this first section of the glob. Here you can see that on problem 4, it's not just the ls command, but ls-a. And there are some hidden files up here. This is a little bit of a tricky thing. So let's do rerun my reset command here. There's nothing inside of this folder. And now let's do touch.hello world, touch.hola mundo, and touch.salve mundo like this. If I type ls right here, we don't get these 3 files. We don't get these 3 files listed because they are hidden files. I'd have to do the ls-a to get those files listed. And the glob, when I do ls star e star, the glob will never match hidden files by default. The glob will never match hidden files. Glob will never match hidden files. And so even though, say this file right here, .hello, even though it has an E inside of it right here, you can see that ls star e star, this glob right here did not match the hello right here. And so .hello did not get printed. Similarly, .salve did not get printed. And so when I do rm star e star like that, and then ls-a, we still have the .hello and the .salve, and so we pipe that to wc-l, and we get the 7 files existing. 6 files created by the touch command up here, 1 of them removed by this rm command right here, and then these 2 special folders that are inside of every directory, the dot and the dot hidden folders right here. Easy to forget these on the quiz. Make sure that you include those anytime there's the ls-a command. Again, the key takeaway from this problem right here is that the glob will never match hidden files. And so don't include those in the things you're predicting it will match. If I were to put an explicit dot in front of the star, so something ls dot star like this, we'll do it with an echo. This will match the hidden files. If we have a dot right here, this will match the hidden files. And so this does match .hello, .hola, and .salve. This doesn't contradict what I said up here because the glob over here, the glob here is not expanding to a period. So the glob is not what's matching hidden files. It's this dot here out front that's what's causing it to match the hidden files. And it turns out that this is a particularly dangerous thing. Dot star is a very dangerous thing to do because of these folders over here. And at least once per year, since I've been here over the past 4 years, I have totally destroyed the Lambda server by using a something like rm.star command, and forgetting that this is going to match these files over here, and so it matches the dot, which is the previous folder, and deletes many more things than I wanted to. So the quiz is going to ask you about things with this dot star. In practice, though, something that you probably want to avoid using because it will match these special folders over here and do lots of things that you probably didn't intend. Any questions at this point? Yes. Question is, so if we have, and let's, if we have star E star, the question is, how is star E star different from just star E or E star? The answer is that if we do not have the star up front, in this situation right here, the file name must start with the letter E. So in this case, there are no files that start with the letter E. If I create a file like Salve here, Salve does in fact have an E inside of it right here at the end, but it does not start with the letter E. So if I do ls E star like this, then we can see that it's still not matching anything right here. This Salve is not being matched, but a star E star, that will be matched. Or a star E will also be matched because it ends in the letter E. If you don't have a star at the end, it means that whatever letters you have here must be the end of the file name. And you don't have to have just a single letter. Most of the examples I've done so far have had single letters. You can have an arbitrary amount of letters, and then all of these letters have to be at the end of the file name. Did that answer your question? Good question. Any other questions so far? Okay, that takes us through all of these, this first section. Again, well, I guarantee there's going to be a problem that has somehow a dot star something in the quiz, because I always mess this up. And so, because I never got in the habit when I was first learning the glob to be careful with the dots. And I want you all to get into that habit so you don't mess things up. And so at least one problem, potentially all 4 problems, somehow related to this dot and hidden files with the star. Okay, at this point, if the glob seems weird, then you we're just getting started on the weirdness. So we'll see all the different weird things that are going to happen with the glob. And again, the Posix shell, very powerful system, but very awkward in certain situations. And the glob, especially combining with the with white spaces, is going to be super awkward. So problem number 8 right here. Let's walk through exactly what's going on with problem number 8. So in problem number 8, again, touch. Now everything is in quotation marks. Hello world, touch hola mundo, touch salve mundi, like this. And again, if I do ls pipe cat, we can see that there are these 6. Oh, there we go. 6 different files right here. Oh, sorry, not 6 different files. 3 different files right here. 6 different words. It's only 3 files because of the quotation marks. But if I do echo star, the star right here will expand all of these things as individual parameters that will get passed to whatever command that I'm using, like echo. And then it'll forget the fact that, say, hello world were grouped together. It will forget the fact that hola mundo were grouped together, and it will forget that salve mundi were grouped together. So if I do touch star, then all 6 of these things will get copy and pasted right here without quotation marks, and it will create a whole bunch of more files for me. Do oops. I apologize. What I just said is incorrect. The star here will remember that all of these things are grouped together as individual files. So the star right here, the white space doesn't matter inside the star expansions, that it will keep all of, it will add the appropriate quotation marks around the things that get expanded. What I said was incorrect because I got ahead of myself. I said that each of these 6 things would be passed in separately to this touch command right here. That's incorrect. The glob operator right here, the star, will continue. It's like it's putting quotation marks around each of the files that gets passed in. And so it's passing in just these 3 files separately. What I said was going to happen was that the touch command right here would create 6 new files, but that was incorrect because these files are getting grouped together. So on problem 8 right here, it's like line 5 right here doesn't even happen at all because all of these things, when the glob expands, it keeps the quotation marks and keeps those 3 files together. So the output here is just 3. Another weird thing on problem 9 right here, we mentioned this briefly, but what happens if there's nothing that the star expands to? It means that the star character itself gets passed to the file. And so if I do touch star like this, that literally creates a file named star like this, creates the file star. And so ls pipe wc-l gives me 1 here for this file name of star. Problem 11 right here. If you have quotation marks around your star, then the star will not get expanded no matter what type of quotation marks you use. So clear everything out, redo my touch hello world, touch hola mundo, touch salve mundi. And so we have these 3 files right here, 3 files. If I do touch, or we'll start with echo, star in quotation marks, a star inside of quotation marks does not get expanded no matter what type of quotation marks you use here, whether it's single or double quotes. And so touch and then star like that literally creates a file called star. And so ls pipe wc-l gives me 4 in this case. If I did not have the quotation marks around here, it's what we saw earlier on problem 8, then it will just be called on each of these existing files, not create anything. And so the answer would have been 3 if there were no quotation marks, but because there are quotation marks, the answer is 4 because it created this star file right here. You have to be very careful when you have files with special names like this because it's very tempting if I want to delete this file right here to do something like rm star, because star is the name of this file over here, and it's tempting to try to delete it just by typing in its name. But if you do that, this star again will be expanded and match all of the things in that particular folder. And so rm star does not delete just this file, it deletes everything in the folder. Rm star and quotation marks would be how you delete just that particular file. And that's everything here in section 1.1 weirdness. Section 1.2 is with how the glob will interact with for loops. Before we go into that, any questions about things we've seen before? Henry first. Is your question, so if we use, so we've seen before that, so the touch command, if we do it on a new file like this, it creates a new file. Is the question, what happens if I rerun touch on a file that already exists? I'll just first answer that, just so that we see the answer. The answer is that here we see a timestamp. Every file has a timestamp of when it was last updated. Touching a file just updates that timestamp to say when it was, whenever you touch it, whatever the current time is, it updates the timestamp to be that time. So that's literally what the touch command is doing when it's getting these new files inside of it. When I think the actual question here, touch, when I'm doing touch star, what exactly is happening? This star right here is getting expanded to, that is equivalent to putting quotation marks around all of the file names. Hello world, hola mundo, salve mundi, like this, and then calling touch on each of these things individually. Again, all of these files already exist. Anything that you get returned by star will be files that already exist. And so it's not creating new files. It is just updating the timestamp for all of these other files. The timestamp part, though, is not something that's involved in the quiz at all. If I change this star, touch star, to be an echo star like this, then echo will not print out any of these quotation marks. So we makes it hard to see that these things were actually grouped together here when being passed in. But if I change it to the touch star like this and then ls-l, you can see that all of these timestamps were updated for each of these individual file names here. Did that answer? Question also? Same? Okay. Good question. Any other questions so far? Okay. Yeah, so I got a little bit ahead of myself earlier, said an incorrect thing. The thing that I said in section 1.1 is going to be what's happening in section 1.2 for loops. And so let's see what's going on here. Let's start with, before we get to problem 13, let's just reset everything in my quiz folder here. And let's touch, I'll do it in the right order. Hello world, touch hola mundo, and touch salve mundi, like this. And then we've seen for loops as a way for file in some list of file names. I can do something like hello world like this. There's a do, and then echo $file done like this. And this file variable right here will take on every value inside of this. We still call the list over here, but it's different than the list in Python because there's no square brackets or anything. In the terminal, lists are just separated by spaces. So for file in this list of words right here, the file variable will take on these values over here. And then on our previous quizzes, we saw that you can put quotation marks around the strings over here. You can put, say, hello world inside of quotation marks right here. And now this file variable will take on this entire thing at once, take on this entire value at once. And so the echo command over here will only print one line. In this case, file gets substituted with hello and world, two separate parameters being passed to the echo command over here. If with for loops, though, it's extremely common to use a glob in the list portion of a for loop, something like this. For file in everything in our current folder, do echo $file like this and hit enter. And here now this glob expands to all of the files in our folder, and we echo them out one at a time. So at this point, everything that we've talked about is really just a review of for loops from our previous Posix quiz. I just then added this star right here for a way to more conveniently create these list expansions over here. The downside of using the star, or sorry, not the downside, the motivation for this is on your Twitter assignment, the analyzing the tweets. You're going to have to write a shell for loop that's going to loop over all of the files in the data sets. And the glob will be the easiest way to do this, something like for file in that folder that contains all the tweets. And in particular, it'll look something like for star.zip, so you only get the zip files that match that. So that's the motivation. But now, again, focusing on the how and the what. Here, again, all of these files are individual words. And so this for loop does what we expect. I'm going to reset the problem right here and redo the touch command with the quotation marks, hello world, touch hola mundo, touch salve mundi, like this. And so now every file here is its own, or has a space inside of it. There's only 3 files right here. And what happens when I use the star command in the for loop over here is that apparently the terminal is not behaving how I was anticipating, because I was thinking these were all going to be on separate lines. So the glob here is still behaving how it was behaving previously in section 1.1, where it's grouping these things together and only printing out the files one at a time. For file in star, do echo. Is it because of what? Question is, should there be a $ sign in front of the file over here? The answer, well, the answer to that question is that there's never a variable over here to the left of the or there's never a $ in this variable right here. Anytime you're defining a variable inside of the shell, there's no $. This is one way of defining a variable. Another is doing something like this. And then you access the variable with a $ in front of it, but no $ in front of this over here. Was that the question or a different question? Okay, that's fine. Good question. Well, let's see. We have seen, so let's get into more complicated for loops now. We've seen things like parameter expansion. If I do echo star, these are the results of this function right here. I can substitute that right here, echo star, and in this case, it will print out everything on its own separate line. That this parameter expansion right here is forgetting about everything that it's forgetting about how the star was keeping files grouped together, and because the output of echo down here, the output of echo forgot how the glob kept things together, and we're just taking the output of echo. It's like copying and pasting this right here. So for a for loop that looks like this, it does not matter how the files were created, whether you have quotation marks around them or not, because the echo command in its output will forget those quotation marks when you pass it to the for loop here. You can see that I'm making a handful of syntax-ish sort of mistakes here in the terminal. That my memory about what's going to happen is different than what the computer's memory is about what should happen. And the computer is our ground truth. It is our source of correctness. I am a puny human. I make mistakes. And so you should be thinking about, okay, if I'm making mistakes going through these quizzes in my head, then it's likely to be a hard quiz with lots of edge cases for all of you as well. That takes us through everything here in the for loops. I don't know if we've seen this syntax yet, putting pipes at the end of a for loop. You can put the pipe at the end of any shell command, not just a program. So this will take the output of the entire for loop. We can take the output of the entire for loop and pipe that into another command like WCL and count the number of lines that get output here with something like this. So the pipe, it doesn't have to be just an individual command. It can be any like complex expression like a for loop or a while loop to the left of it or to the right of it. Any questions so far? Okay, security issues related to the glob. So glob expansions happen in the shell before the parameters are sent to the program. We've talked about that before, but this can have lots of unintended side effects. So we're going to take a look at problem 17 and problem 18 here in turn. So I'm going to reset everything like this, and reset the screen. And this problem has us saying touch test is problem 17, the first one here. And so we have this folder here. And if I wanted to do something, or if I did do something like rm star like this, and type ls, you can see that that has deleted this, this file here that I created called test. The rm command, though, it has this special behavior that if you create a folder instead of a file, the rm command by default does not delete a folder because you might have a lot of things inside of there, and so it forces you to actually specifically say that, yes, I know this is a folder and I want to delete this folder. So something like -r over here. The r over here happens to stand for recursive. So the rm function over here with the -r is implemented recursively going into all the folders and deleting them and the contents of their file. Do that, and that would delete this file right here. So in problem 17 right here, there is no -r on line 3. There is no -r right here. So we do not delete this test folder, and we still get it printed out on line 4. So there's nothing. Make dir test rm star gives us this error message saying that we can't delete it because it's a directory, and so we still have it there when we do the ls command right here. Problem 18, though, looks very similar because we still have this rm star right here. But now, let me go ahead and clear everything. Okay, there's nothing in here. Let's make dir test. Now let's do this echo evil into -rf right here. And now when I do this, if I type ls right here, we can see there's an actual file that's name is -rf. And so if I do the parameter expansion, something like echo star, then we can see that this star is going to expand to -rf and to test. And so when I do rm star like this, rm star, and I hit enter, this star will be equivalent to star expanded to -rf test like this, and I hit enter. And so it's going to delete the test folder for me because it has this -rf flag passed in. But we'll see that it actually does not modify this -rf file in any way. So in particular, if you have files that start with dashes in your folders, it's very likely that those files are going to modify the behavior of your executables when you're using the glob if you don't take precautions. So this is something else that I make mistakes with in the terminal on a too often basis and destroy computers with. And so you can expect at least one problem, possibly all 4 problems on the quiz dealing with this behavior right here. Again, I'll just explain what that behavior was. I created a new empty problem, nothing inside of it. Then I created this test folder and created a file -rf also inside of here. So -rf and test. And so this glob right here, this glob is expanding to -rf and test. And so rm star right here is equivalent to rm-rf test. This is a special flag that is for the rm program that says, I know that thing over here is a folder, so delete it. I don't care. And so it does not delete the file -rf, but it does delete the file test. Question, Miles? Question A is, does the order that I created these files up here matter? And the answer is no. So if I first do an echo evil into -rf right here, and then make dir test like that, we still have the same contents inside of the folder. And so when I do rm star, the same exact thing is going to happen. So this begs the question of, how do you avoid this this sort of behavior? This is potentially disastrous behavior, especially if if you're working in a folder that somebody else has the ability to create files inside of. If somebody else could create a file that's -rf and you're not aware about that, they can change the behavior of what your scripts, your shell programs using the glob do. I know of that this is it's not the most common security vulnerability that happens, but I know every major FANG company, like so Facebook, Microsoft, Netflix, Apple, all of those companies have had critical security vulnerabilities because of this happening inside of a shell script that somebody wrote. Where somebody was able to create a file like this and change the behavior of a server process. So how do we avoid this security vulnerability? And there's two ways to do that. Line 19, problem 19 here illustrates the first of those. On line 4 here, you can see that instead of doing rm star, it's doing rm./star. So here, let's go ahead and make dir test again. So here's my setup. I have -rf and test. If I do ls, we'll do echo star. That gives me the -rf in the test. If I do echo./star like this, now this puts a / in front of all of my file names, everything that gets expanded with the star. Because again, the star, all it does is it expands the file names. Anything else that's not part of the star is guaranteed to be reproduced verbatim in the path. So now we have ./-rf and ./test. When we call the rm command on ./-rf, now this is different than -rf. These two things right here are different. They get interpreted differently by the rm command, and the rm command realizes, okay, this is actually the name of a file instead of these special parameter flags to delete. And so that well, it actually removes this thing over here. It does not remove the test because now we don't have the -rf flag telling that it's safe to remove the test. So this is the first way to avoid this problem, ./star. A excellent habit to get into is anytime you're using the glob to always put a ./ in front of it or always put some sort of path in front of it. And that will save you from 99% of these security vulnerabilities. And this ./ something, again, this is built into the shell. And so it's not something that you have to, that like individual programs have to take advantage of. All of the Python programs that you write will automatically be do the right thing if you have this ./ in front of your star. The other option is illustrated in problem 20 over here, where we, on line 3, we can see there's this -- right here. So let me reset this problem here. Let's make dir test like this, echo evil into -rf. So it's the same setup right here. But now if I do rm -rf test, we'll start with this first. The -- means that everything that comes after -- is not a file name, but is not a flag that changes how this behaves, but is actually a file name. So this says, okay, this thing over here is no longer, it can't be a parameter to rm because it happens after the -- So if I do that, then it interprets this as the file name and deletes it. There is no -rf flag, so it does not delete the test folder here. This is back to the same setup as before. I'll rerun that same rm command, -rf like this, putting the -rf in front of the -- Now this will not be interpreted as a file name, but it will be interpreted as the parameters to the rm command that changes its behavior. And so the test folder here was in fact deleted, but the -rf file remains intact because this is not the file name. This is the parameter to the rm program. This the -- is not built in to the shell. And so it is something that user programs must implement. All of the standard Linux utilities, all of the standard, call them the GNU Linux utilities, Linux itself refers to the operating system. All of these commands like ls, rm, make dir, these are implemented by the GNU. The cool way of pronouncing this is pronouncing it with a hard G out in front. GNU instead of new, like the animal, it's GNU. And this is a standard that in the 80s, 89, they adopted this as a convention specifically for these security reasons. But this is something that programs have to implement, and most programs do, but it's not guaranteed. So using this // is the safer thing to do. There's a good stopping point for us for today. If people have questions, happy to take them after class, whether it's about this or about the heap or about anything else. Otherwise, again, recall on Wednesday, you'll have the 2 quizzes, Posix 1 and Posix 2. So I have 16 minutes to work on it in class, and I will be here very early just to ensure that you will not be time limited in any way. But see you then.